Hello, everyone, and good morning. We bring you the 17th episode of Super 30. If you have been following us over the last 16 episodes, we've brought in some great information about the HVAC industry and policy matters that can impact the industry. Today, we're going to bring up a very important topic on sustainability. That is, how do you minimize the refrigerant emissions through leak proofing? This has been a big issue. It has a direct impact on our environment. It also questions our understanding on sustainability. We're very fortunate to have CEEW as a partner who's brought in some great inputs around these various topics that concern our industry. So today, I'm happy to invite you, Aditya from CEEW, who's going to lead this discussion and take up this topic. Over to you, Aditya.
Thank you, Ajit. Thanks for the introduction. And I also would like to invite now Mr. Jitendra Bambure, who is Technology Advisor to the Blue Star and CW as well. And I will also like to invite Dr. Ruchi Grover, Director and Founder of Oxycoats, which manufactures the anti-corrosion coatings and the other equipment as well. Today, as Mr. Ajit told, that today we will be discussing about minimizing refrigerant emissions through leak proofing. Right? We are all very aware how harmful these gases are for our climate and for ozone as well because of their high global warming potential and their ozone depletion potential. Well, how does this emissions happen in the first place? We all know that during the operational life, which is the 10 years or the 15 years of the cooling systems, let it be refrigerator or air conditioner, the refrigerant get leaked out of the system. And the other point is when it reaches the its end of life, जब वो खराब हो जाता है, जब हम उसको बाहर फेंक देते हैं, तब जो कबाड़ वाला रहता है, तब भी उस गैस को निकाल कर बाहर कर देते हैं. So these are the 2 points during the 10 years, 15 years, and once at the end of life. Today we will be focusing on the ऑपरेशनल लाइफ ऑफ द कूलिंग सिस्टम विच इज 10 to 15 years. यहाँ पर जो लीकेज होता है उसको हम कैसे कंट्रोल कर सकते हैं, किन कारणों से ये लीकेज होता है, what are the measures which are available in the market which we can avoid these kind of emissions, and we will delve into these aspects of it by asking our experts, Mr. Ajit, Mr. Bhamure, Mr. Dr. Ruchi Grover, the questions which will help us to achieve sustainability in the HVAC sector by minimizing the leakage emissions. So, without taking much time, I will firstly ask Mr. Bhamure, what is the primary reason because of which this leakage happens in the first place after it has been sent into the market or it has been installed in our homes or the institutions or the buildings, right? So, what causes it? Uh, I just want you to take a few minutes to explain to our viewers what is the primary reason, what are the different factors which affects the which impacts the emissions of the refrigerants during operational life.
Okay. So there are multiple reasons. We cannot have, say, one primary reason or anything of that type. It starts from the design and validation of the design. For example, if the product is not validated for the strains that will come on the piping, it is not validated for leak proofing during the manufacturing, if it is not validated for the transport worthiness, then what happens is the product, when it comes to the installation, there is something that has already happened to it, which needs to be valid, which should be done first. The second comes during the installation. Now, if we look at 80% of India's requirement is in split type air conditioners, and if it is not installed properly, using proper tools, using proper torque wrenches for connecting pipe into indoor to outdoor, that can potentially create stress, and which will result in cracks and eventually. So these are the product related and installation related issues. But there are other issues which are related to the environment in which these machines are installed, and that will fairly depend on the ambient ambient corrosive factors that are there, be it saline atmosphere, be it near the waste dumping grounds, or जो नोएडा के और मालाड एंड इन ठाणे साकेत के जो जो ओपन गटर्स है और ओपन वेस्ट वाटर स्ट्रीम्स है, उससे जो एमिशंस होते हैं उससे काफी काफी तक होता है. So so this is on the outdoor unit. Now, if you come to an indoor unit we feel that indoor unit में कुछ नहीं होता है और कॉपर तो खराब होता ही नहीं, बट ऐसा नहीं है. There is something called a formicary corrosion, and वो formicary corrosion happens because of the volatile organic compounds that are there in a house, which get emitted. और जो लास्ट जो है वो आई वुड से कि it is all related to structural stability, ambient condition में working कैसा है, एकदम high ambient में आता है, pressures beyond point जाते हैं because of poor maintenance, coils clogged and all these things, and then it crosses the boundaries and it can then cause the ruptures. So these are, I would say, very, very broad points which cause the leakage during operational life.
Thank you, Mr. Bamure. Again, I would like to ask one more question. What measures, since you belong to Blue Star, you have been technology advisor and headed the R&D department there as well. What are the measures OEMs take from their end so that to avoid the emissions which happen because of the environment conditions? As you have said कि अगर गटर का पानी आ रहा है वहां से अगर पास हो रहा है तो वहां से जो सल्फर डाइऑक्साइड वगैरह निकलेगा उसके कारण एमिशंस होते हैं, या फिर वोलेटाइल ऑर्गेनिक कंपाउंड्स जो घर के हमारे अंदर के हम प्रोडक्ट्स यूज करते हैं उनके कारण होते हैं. व्हाट आर द मेजर्स दैट्स द इट इज बीन टेकन एट द डिजाइन स्टेज ऑफ द प्रोडक्ट?
So design stage में अभी mostly जो the first attack that comes is at the brazing joints, and most of the manufacturers have also now started उसको जो जिधर रिटर्न बेंड्स है जिधर पे उधर कोटिंग करना चालू किया उन्होंने, different types of coatings. Okay. The second one is जो fins है वो fins में the coated fins यूज करते हैं, normally known as blue fins, एंड वो उससे क्या होता है कि एल्यूमिनियम और कॉपर के बीच में जो इलेक्ट्रिक बॉन्ड जो तैयार होता है जिसका जिधर से वो करोजन शुरू हो सकता है, that gets eliminated. Plus fins also last for a very long time. Now apart from that, the leak proofing testing is done in a much rigorous way. Helium leak detection is becoming very, very common. Similarly, as I said, transport worthiness उसके टेस्ट है, आईईसी के टेस्ट है, एएसटीएम के टेस्ट है, वो टेस्ट से करते हैं बिकॉज वी नो इंडियन रोड्स कितने खराब है, एंड बाय द टाइम वो रीच नहीं होने, बाय द टाइम इट रीच इट शुड नॉट गेट डैमेज्ड. सो एट द सेम टाइम देयर आर एडवाइजरीज given to the dealers, contractors, and we train the technicians also that look at the environment in which is likely to get this thing, and then there are standard advisories given that the coating should be done, but that usually comes at an extra cost because ये जो emissions है either at the sewage के जो canals है और sewage जिधर से waste होता है, the units installed there will be maybe in a single digit number of the total units installed in India. तो उसका वजह से देयर इज एन एडवाइजरी गिवन कि ऐसी जगह है तो कोटिंग करो.
ओके, थैंक यू मिस्टर Bambure. Ajit, as Mr. Bambure pointed out that advisory has been given to the dealers and the people who are working on the ground that you must be using the coating, right? But before going there, I would like to ask question that there are many aspects that Mr. Bambure told that during the design stage it has been considered कि leakage ना हो, emissions का corrosion ना हो, right? But still 40% of the consumption of refrigerant is coming from the servicing sector. Why is it happening? Because why is it happening? I would like to ask because measures लिए भी जा रहे हैं OEM side से, but still it is happening. Why?
So Aditya, this is not a top priority for the industry. I'm being very blunt about it. It is not something they even connect to when it comes to sustainability. Do I want a good planet? Yes, of course I want it. But is that top of my priority right now? No, it's not. Because right now, majority of the MSMEs are struggling to have a sustainable business and a decent profit. That's one issue.
Right.
The second issue is all about skilling. You know, most people, there are, I mean, can you imagine there is a country which has a billion over population which needs jobs, and there is a whole industry which cannot get people to work for them. That, what a strange
Right.
irony is that. And the majority of the problems which comes when the servicing issue is also because there's no certification in this industry. Anybody can become a technician. More than 50 to 60% of the people have learned on the job. So they have learned what they have to. They haven't learned everything they should be knowing about the industry.
Right.
Refrigerant management is very far-fetched here. Nobody even, we have, even, it's a big task. It's a ticking bomb on us, and it's very far-fetched. For example, you say the OEMs have given directives and everything. OEMs have given directives, uh, but it's not effective because there is no incentivization around it. Forget about refrigerant recycling and anti-corrosion. Even for the current incentive to do servicing, to maintain these equipments, the service providers are not motivated because they don't
Right.
get remunerated the way they want. So they are happy to just sell and install. That's it. And then servicing, if it comes, it comes. Otherwise, let it go past. Let it be somebody else's problem. So refrigerant and corrosion is still far away. So it's a very complex problem. It has to get corrected on multiple fronts. So to sum it up,
Right.
it's got to do with incentivization, it's got to do with skilling, and it's also got to do with regulation. All of these three needs to be tackled properly. Only then you will see some real impact at the ground level.
Right. On top of it, as Mr. Bhamur also told, that the environmental conditions differ from city to city, from place to place, right? So,
Yeah.
OEM can make a product which is suitable for across the country, but they cannot make a product which is aligned to a city or the area specific, right? Coming to
So Aditya,
Dr.
I'll tell you.
Ruchi, yes, yes,
Sorry, Aditya. Let me just add to this since you brought it up.
sure,
See, that
sure,
day is not far when the OEM will be forced to do it because
right.
with the advent of data analytics, okay, one of the things
Mm-hmm.
that is clearly working out is, pin code wise heat map will be get created. It's a matter of time, and I know of people
Right.
who are working around this across the
Mm-hmm.
country. Over a period of time, you will get pin code wise heat map, which will clearly, like how he mentioned, Saket, or he mentioned Thane, or he mentioned Malad, they're all marshy land. They were all reclaimed with garbage. The sulfur content is very high, which is what forces the corrosion to a very different level. So you can, over a period of time, using this data, you will create a heat map which will say that, these products need X amount of corrosion here. These products
Right.
already have it. And once that data gets democratized, it will push a lot of the people to take corrective measures. And I personally believe that's also one of the ways that this will take off.
Right, right. So until it gets
Well,
mainstreamed, and yes, Mr.
Ad-
Muhammad, I will come with you
okay, okay.
in a minute. Yeah, until we reach that technology level and it gets mainstream that we are using the heat maps for asking OEMs to send the specific product to a certain place. Dr. Ruchi, what are the measures which are currently available in the market, which can avoid the refrigerant emissions to happen because of the corrosion which happens in the HVAC systems? If you can shed a light on it, it will be very great for our viewers.
Yeah, sure, Aditya. Before telling you what are the measures available on your observation on OEMs these days, since we are working closely with OEMs for anti-corrosion projects, now even OEMs are taking a step ahead. They have customized models like anti-corrosion models for the specific areas where corrosion issue is very high. And OEMs are also driven by consultants. If a consultants mention in their BOQs, in their design, HVAC design, that the installation is near a drain, or it's near a salty area or a saline environment, so they are also supposed to mention, if they mention that the installation should be along with anti corrosion coating, so OEMs are then bound to get the anti corrosion coating done either on site or in their warehouses or plants, whatever. So right now, what you asked me is like what solutions are already available in market. So see, what I have observed, there was a practice of using a aerosol spray coating for residential air conditioners in market past 10 years. This is a traditional practice which I have seen. So these aerosol spray coatings, since they are single pack, means they are quick drying acrylic or one pack polyurethane based material. So they don't have a very good life on these. For corrosion protection, but still they are a good measure if they are applied on a new machine. So what we recommend is, if instead of installing a machine without any coating, at least minimum to use a aerosol spray coating which is available in market, so that it gives a protection for at least 1 year or maybe 6 months, and this will really help in achieving the warranty cost, and even the whatever the AMC cost is there, it is included in the service thing. And other things which are available now in market are the coatings which are epoxy, hybrid epoxy based are available. Even polyurethane based coating are now available in market, which are two pack systems. The consumer has to mix these two coatings, the resin and the hardener, in a specified ratio, and then they have to apply it on these copper U-bends in joints. So if they apply these coatings on copper U-bends in joints, they can definitely help, to minimize the rate of frequent gas leakages, and also the subsequent coil replacement rate can be controlled.
Okay.
So
And
plus
how?
there are service providers like we are also doing the same job. We are doing projects for OEMs and for um, the contractors and SSD segment, which, and we give the apply and supply support also for the commercial air conditioners. So if skilled labor is an issue, and the SSD, they don't have people who are skilled enough to do anti-corrosion coating on VRV units or air-cooled chillers or whatever the indoors linked with these AHUs, for example. So we provide a complete appliance supply and support in the industry, so that we can support the industry from these frequent refrigerant leakages.
Right. One question, since you are involved with the OEMs as well and the SSDs as well as you talked about. So,
Yeah.
if you are involved with SSDs, it has to do with after the product has been placed in the market, right? What skill
Yeah.
sets one servicing technician needs to apply these coatings in the HVAC systems? Is it very hard, or any new person who has got trained in the HVAC industry can apply it? What is the process? Basically, I want to ask.
See, for a RAC or a window AC, any AC mechanic who is able to open the machine and do the breathing and fix the joint and refill the gas again can do the coating also. So it's not a
Right.
rocket science. Only he must
Mhm.
be, if he is using two pack systems, he must be aware of the mixing ratios. So which are mentioned on the manuals and videos also, which are now available on the internet, how to use these coatings. So not a very specific skill set is required when an residential AC is concerned. But when it comes
Mhm.
to a commercial air conditioner or a chillers and AHU, then the major skill required is the know-how of dismantling an IDU unit, so that they don't disturb the wiring and the connections of the indoor unit. So once they know how to dismantle the unit, bring the coil out, then they can easily do the coating on the copper joints and aluminum fins, and then they can reinstall the coil back in the IDU unit. And similarly for the audio unit, they should know how to dismantle the machine first. Then they should know how to protect the sensors and the sensitive parts before they start coating.
Mhm.
And
Mhm.
thirdly, they should know how to operate a spray gun and air compressor system, which is required for the latest technology which is being used these days. So we train people, we train SSDs, we give demos also, and this is the way we are trying to teach the mechanics and people how to DIY these coatings
Right. Right.
themselves.
Right.
Yeah.
Mr. Ajit, since Dr. Ruchi told us these are the measures which are available in the market, how have over the years they have been scaled up? Is it being adopted in the industry as of now by the SSDs, by the MSMEs?
So it's completely need based. right? So I'll tell you there are two use cases where it actually happens. One is where if there is a project which has been insisted that you need to do a coating, you don't have a choice, you will do a specific coating. And in most cases, you would end up taking the machine, you will dismantle it, you will do the coating, probably at site or at a workshop, depending on the size of the project, and you will end up doing it. The other thing is where there are organized service providers, pretty large organized service providers who have understood the fact that this refrigerant leak can be a drain on their profitability, because
Okay.
this our industry runs on annual maintenance contracts, right? So in that
Right.
annual maintenance contracts, refrigerant leaks, it's a loss of revenue. So these people have understood that, listen, this is my mainline business. By default, let me quote and send it across. So I stand to benefit out of it. So,
Oh,
but it is, in terms of ratios, it is very small. It's just a handful of people, not big enough to make any big impact to what you're trying to achieve from, from a sustainability perspective or from minimizing the damage of emissions.
right, right. But when we talk about cost, Mr. Bhamara, I would like to ask you this question. Since Ajit told that they can usually benefit from if the emissions of refrigerant has been controlled during the operational life, what are the other impacts or benefits which MSMEs can achieve or the consumer can achieve if the leakage or the corrosion is controlled of the system, right? What is its impact on the technology of the system?
So from consumer perspective, the biggest barrier today is the awareness with him. He gets directly benefited because usually what will happen is if a refrigerant is leaking, the the impact that the unit is not cooling now adequately will come after some 25-30% of refrigerant has leaked. Okay. What
Right.
is happening then is system is not operating at the design conditions, which means that it is running for longer time and means that is paying for a higher bill. Apart from that, he has to, he has to call the technician and refill the refrigerant. So from consumer point, it is very very clear because if his product is there for a long time. But as Ajit said, that it is becoming need based. Consumers are not aware. Consumers are very clearly aware that I have to take my vehicle and get it serviced 2 times, 3 times as per manufacturer's recommendation. But here it is not happening in case of the specifically in case of the smaller systems. Now, what are other benefits apart from the leakage and other things? One is to the consumer. The workforce that gets into in a peak summer, because anywhere in India it is a air conditioners used for 3 months, 3.5 months time. The workforce that is required to attend the calls will be greatly reduced if the units are properly working properly. And that will bring down the strain on the installation and availability. We have to understand that with a 12% to 13% growth rate, room ACs are going to double every 6 years. See, today this is about 1 crore ACs were manufactured. Okay. Now it is only by 26, 27 or 28, it will be 2 crores. So where will you get such a manpower? And as Ajit has said, that it is with a warranty, extended warranty is given. Manufacturers want that air conditioners should function normally. However, there is what I can say is, which also Ajit said, if the technicians are not well paid, then they will find out ways and means of adding the revenue. And uh, topping up a refrigerant is a big business model for them. Okay, they will say refrigerant sir cooling nahi aata hai, maybe it is because of clogged coil. They will say refrigerant sir, refrigerant ठीक नहीं है, हमें टॉप अप करना पड़ेगा, और वो जूना है रेफ्रिजरेंट, तो खराब हो गया, वो पूरा निकालना पड़ेगा. सो एक बार रेफ्रिजरेंट भरने के लिए दे विल चार्ज एनीवेयर बिटवीन 3,000 to 4,000 रुपीज, वाइल इंस्टॉल करने के लिए उनको कुछ 500-1,000 रुपए मिलता है. ओके, तो
Correct.
ये इससे बाहर कैसा आने का वो हमें प्रॉपरली सोचना पड़ेगा. सो कमिंग टू दिस ब्रॉडर टॉपिक इज, ये इंस्टॉलेशन फ्री है ना, इज ओनली इंडिया थिंग. इट इज नोवेयर इन द वर्ल्ड, because otherwise if you go to Europe and US, installation cost is as good as equipment cost. ये installation free बोले तो कुछ भी कैसा भी करके खत्म करने का और मैक्सिमम एयर कंडीशनर्स इंस्टॉल करने का, सर्विस करने का, कुछ भी करने का. एंड दैट इज वेयर द फंडामेंटल इश्यूज आर लाइंग. So with all this, corrosion coating, taking care of corrosion and everything becomes has taken a secondary seat completely.
Right. Dr. Ruchi, coming to again to the point of the anti-corrosion coating or leak proofing, you have been in the industry. If we apply these anti-corrosion coatings in the systems, how impactful are they? Since Mr. Mamure told that th- initially there is a 1 to 2 year warranty, they want it to be like that कि refrigerant leak ना हो, system efficiently perform करे. अगर हम लोग मार्केट में प्लेस करने के बाद अगर हमने ये कोटिंग किया, हाउ इम्पैक्टफुल, हाउ मच लाइफ डज इट एक्सटेंड ऑफ द सिस्टम? डू वी हैव सम नंबर्स और फिगर्स अबाउट दैट?
Yeah, what we have observed is that people, the SSDs, the commercial air conditioner guy, they still allow, or the OEMs allow to do coating on the new machine for the new installations. But there is a myth or some confusion that RAC guys, they don't do coating on the day one. वो ऐसा सोचते हैं कि हमारी coil की warranty चला जाएगा, या हमने बाहर से कोटिंग कराया तो फिर हमारी कॉइल रिप्लेसमेंट में इश्यूज आ जाएंगे. तो आई वॉज सपोज टू, और मे बी आई वॉज अबाउट टू राइट टू द रामा हेड or the manufacturer's head that if this confusion can be cleared from market, that coating a new machine is always good for a coating. It will definitely enhance the life. Coming to the numbers, if we coat a new machine with these available technologies, especially the combination of polysiloxanes and epoxies, then up to 80% gas leakages can be controlled for up to 2 years. If we are allowed to, do this on the new machine itself. When the machine becomes older, the corrosion is already began on the gauge is compromised. When the gauge becomes thinner day by day, year by year, then the fittings also become very prominent on the gauge, and finally the gas leakages starts with formatory corrosion and sulfur in the vicinity, or maybe high saline environment. So what I believe is that the justice to the machine, if we are doing the coating, it should be done on day one itself, on the installation, the first year only, and so you will get the maximum benefit out of the coating. If the coating is done in the second year or the third year, from 80% it will decrease up to 50%, or maybe 35 to 40%, because the gauge is already compromised, the corrosion is already being initiated. So that is what we have.
Great. So combining the points Mr. Bhamure and Mr. Dr. Ruchi told, Mr. Rajita, I want to ask you one last thing, and after that, I would like to close the session as well. Mr. Bhamure said that people are getting more aware about getting their systems serviced regularly, right? And people are moving towards AMC day by day, and it's not many times away, many years away that most of the population will be using the AMC system just like we use for the cars, right? And like Dr. Ruchi told that applying these kind of coatings can extend the life up to 2 years or reduce the refrigerant emissions by 80%, right? And it can be effective for 2 years. What other benefits it can offer to MSMEs? I would like to ask from you in terms of energy efficiency, power consumption, right? Overall life of the system, and for the overall circularity of the cooling sector, we have, which we are going to witness more and more in coming years. By 2047, 37, we are saying that the penetration will go up to 50%, 48%, right? What are the benefits MSMEs can get from avoiding these kind of corrosions to happen in first place and avoid the refrigerant emissions, please?
So first of all, we need to understand where the MSME makes revenue. He has three revenue sources. One is he sells an equipment. Selling an equipment gives you the least return because you are competing with larger organizations. You got online, you got modern retail, everybody. So it gives you the least. Installation, which was another revenue, like Mr. Bambure said, has become free, and they made a mockery out of the whole thing. Complete mockery, because by giving that free installation, you have literally told the customer that, listen, installation is like a plug and play. It's not something which is very complex. It is not a plug and play. We all know that aircon installation requires an X amount of skill set and time to put it together. But unfortunately, that is not there. So the possible revenue for an MSME is the servicing sector. And if you are in the services business, and if you can cut down cost by these unnecessary failures of refrigerant leaking and everything, and doing regular maintenance and increasing the durability of the machine, the long term benefits are much, much higher. It ensures a consistent revenue. You can break the seasonal or the cyclic nature of this business by having a consistent revenue. And energy efficiency is win-win for everybody. A customer also benefits, the planet also benefits. And why should we waste energy when we can save it? Not by cutting down our usage, but by working around it intelligently. And I think MSMEs have a huge opportunity here. What lacks is knowledge. What is important, you need to educate them. They lack the skilled manpower what is required for this, and a little bit of hard push which has to come through regulation. And I think these three are the critical things to make this thing happen.
So Aditya, just to add, like that is the reason why Ishire took, initiative to, publish a book on corrosion, which I was fortunate enough to lead it. Okay, so I would suggest that everybody should read through that book. One, second, that awareness, just a simple language which customers understand. For example, if a 1 kg of 410A leaks, which has got a GWP of 2000, is equivalent to 80 fully grown trees that absorb equivalent carbon dioxide in 1 year. Can you imagine how important it is? And so there should be push and there should be a pull from the customer also.
Right, right. Very well taken, Mr. Bambure. I would like to now hand over to Mr. Ajit to close the session.
No, I think it's been an interesting discussion. I mean, what I really like is the whole thing of moving away from just PowerPoint presentations and bringing in expert inputs into this whole thing, because that's how the industry understands quite a few of the things, that, what is the problem, what is the impact of the problem, and how you can fix it, and what are the probable changes that we need to bring on board. So thank you very much to CEW. Thank you, Aditya, for actually bringing this topic up and putting this panel together so that we could get the message out there. Thank you, Dr. Grover. It's been nice to have you to give us a perspective from the point of being one of the suppliers towards the anti-corrosion things. Mr. Bambure is, as I also told you, is always the most wanted man when it comes to HVAC industry. So I have read that book, that corrosion guidebook. It's fantastic book, very well written. And that probably could be a guidebook for most of us to understand the depth of the corrosion and the impact of it. So thank you, everybody. It's been wonderful on a working day at 11 o'clock to actually talk business, and which could have a big impact, not only in our industry, but also in our business profitability. Thank you very much. Thank you, everybody. Thanks a lot.
Thank you.
Thank you so
Everybody.
much, all.
Thank you, Aditya.
Thank you. Thank you.
Thank you, Aditya.
Thank you, Dr. Ruchi.